We will now introduce the next speakers, Estefanía García and Carlos Caballero.
Es el momento de conectarnos con Málaga, España. Hermosa ciudad conocida por sus hoteles de muchos pisos y los centros turísticos que sobresalen de sus playas de arena amarilla. Desde allí nos acompañan dos excelentes speakers, Estefanía García, ingeniera de software, y Carlos Caballero, profesor y full stack developer. Este carismático equipo nos hablará acerca de las arquitecturas escalables para las aplicaciones en Angular.
How are you doing? We're very happy to be here. How are things in Spain? Well, gradually, it's like an accordion. It goes up, it goes down, and in Malaga, we're fortunately okay, well, considering the circumstances. What time is it there? It's 4:45. So great. Are you ready? Are you nervous? No. Okay. So let's begin. Okay. Thank you, everyone, for the development in Angular. I'm sorry, I'm hearing my own voice again. We want to thank NGRX in Colombia for this wonderful work. We also want to thank all participants for sharing your time with us on a Saturday. So in this presentation, we're going to talk about how to create applications in Angular with a scalable architecture. So I will introduce Estefania now. So with the package, everyone working in Angular will know that this tool, you can install it, and it will help us eliminate all those devices which are consuming space. I will create a t-shirt someday with our logo. So I'll introduce Carlos Caballero. He's a PhD in IT and he's a professor at a university and the Google expert in Angular. So that's super great. Since talking about us might be a bit boring, what we're going to do now is talk about the projects for the community that we work on together. We come from Malaga in Spain and we're organizers of this project. For those of you who don't know where Malaga is, it's to the south of Spain and you were all invited to come next time. In this promotional video, you were able to see how wonderful this city is. Apart from having this project Angular community, it's a space where you can find information on all Angular communities around the world. So if someone wants to participate and contribute, you're all welcome. If someone is setting up a local Angular community, you can join the project. We already have about 100 of them. And apart from this, we started a technological publication in Spanish. Why? Because it's lots of us who speak Spanish in the community at a high level, and we're every day working in English. So a new initiative is to have technical content in Spanish, combining that in English, and this publication, you see it here with the logo, and you can follow it. And finally, we're going to tell you a secret that we're working on. It's basically a project where we want to train in quality, but very shortly we will announce it in our social media. Okay, Stefania, so what are we going to talk about in this presentation? First of all, we're going to talk about the architecture theory, and we'll see step by step how to structure a project without any type of architecture and how to make it into a scalable architecture gradually. Okay, so no one has to get scared, even if you see these complicated technical terms in English, but it's relatively easy. So let's begin, Stefania. What's this thing about architecture? Well, a person called Martin Fowler who wrote about IT. Is it familiar to you? Yeah, I was very young when I was reading his book. I have heard about this person. Well, according to Martin Fowler, this is not the only definition of architecture. He says architecture is a word we use when we want to talk about design, when we want to make it sound, very important, but want to puff it up to make it sound important. That's what Martin Fowler says. So tell me something that a bit more concrete. Although Martin's definition is wonderful, we're going to give you a more technical one. The book Software in Practice gives us this definition of architecture you see on the screen. It's the set of structures composing a system, uh, about system which comprise software elements, relations among them, and properties of both. But what does this all mean? Well, basically, architecture means to try to make our software be organized and have quality. And what does this all mean? Well, quality, it's like architecture, a term which it's a scared. Quality as such cannot be measured with only one parameter. There is a consensus of 12 attributes which allow us to define what the software quality is of an architecture. Both in Angular and in any other technology, what they try is to maximize these aspects. Even if we want to, not all projects need at least 12 attributes. Some will maximize just a set of all of these. I'm not come here to talk about scalability. It's just one of the points, and we're going to focus on that point in Angular examples. If we maximize a point and we go to the point of quality, naturally we will be able to improve the other ones. For example, performance or interoperability. Well, wow, Carlos, I can see you're a PhD in IT. Well, now we all know what that software needs to be quality, but let's be honest, in the world and in the internet, there's lots of codes which work, which have no architecture, and which generate millions of euros. So why is it so important for the quality of software to be good? Let me show you a graph to answer that question. Here we have the PHP, the Unidirectional PHP full of dollars. And I am going to show you a graph so that you can understand why the quality of the software needs to be taken into account. We here see two projects. The blue line will be one project taking into account the parameters of quality. And in brown, we see the one that doesn't take quality into account. So what happens? At the beginning of the two projects, you can see how the one which no quality becomes more profitable in time. And let's clarify this. If you're going to do a prototype and you have a minor project, maybe it's not worth applying all these criteria. On the opposite, if the project will grow and will continue, just like the graph shows you, to the extent we add functionalities, it'll become more profitable. In the end, it means more money. And in the end, entrepreneurs who are the ones who pay for the salaries of developers, that becomes interesting. So let's be honest. We're here to talk about Angular and not about theory. So I don't know if you remember the legacy project. Oh, yes. That's what we're seeing on the screen, the super application of Dragon. It's basically a management application in the world of Dragon. We have a basic login to have the panel of administrator and the different modules, like the control panel, the characters, competence, so the contest, and all types of information about Dragon. There was a new saga of Dragon Ball that I remember. The project was not doing very well. That's right. At the beginning, well, this is the studio architecture we had at the beginning. To have things and say that there's no architecture, it's exactly the same. If you notice, Yes, please explain. Well, this cannot be really explained, but we have the app module, which basically was the loader of the application, and we used it to load two different modules. The shared module, which is shared, where we have some components, the components of the layout, footer, etc., all the components of the design. And then we have other components related to the control panel. Apart from this, we have the super gigantic module, and this should never be done. You should never create a gigantic module, and it contains, in turn, all the other modules organized by pages. Oh my God, Stefania, you know perfectly well this modular design. I think you should explain a bit about this. Yes, modular design. We have nothing about this. In fact, when we have a project, we need to structure it by modules. So let's see how we can obtain this in Angular. Okay. So the first thing we need to do is divide our application by features. What's a feature? Each functionality in the application. So we can take our gigantic application and divide it into little or small modules which are more manageable and are better organized. Apart from this, we will create these special modules that you see here in pink, post shared modules. These are the shared modules which will contain the components and the different things that will be shared amongst the other modules in the application. If you notice, there isn't just one shared module, but you have several ones shared throughout the application. And of course, the loader up module, we have to have it because that's where our application begins. And we see in gray something called the core module. What is it? Well, the module contains all the logic of initialization and configurations of our application. So in order not to have such a super growth, then we just separate that module code and take it to the app module, which will have all these applications. Well, the truth is, I'm starting to like this module. Yes. You know what I would talk about now? It's a bit about the features modules that we have. Okay, yes, great. According to the official documentation, I am going to tell you about the existing documentation. We at the beginning had up to 6 types. The domain ones, they normally revolve around the problem we want to solve. Each one of our projects will have a different domain module. Then we have the routing modules, which are the lazy ones. It's deferred loading to get the routed modules. We have routing modules, which are, for example, ones that are you see in here, and they will allow our modules in the domain to be routed, that is deferred or lazy mode, which would allow this performance in the application. And also shared modules, so dark red, they ones containing different widget modules, components, etc. So those are the components that we will share in our application. I think this one is ready. Now we have our application organized by modules. Wow, that's great. I tell the theory and you talk about the practice. So let's continue. Yes, because so far what we've done with our application is organize it by modules. But an application doesn't only have modules, it also has components. So we need to organize it. So let me tell you about the theory. That's what I like. So in principle, we can differentiate between different types of components. The used ones, they usually are containers of our components. We would have one of these per page, or sorry, per screen. Then we would have the very smart ones, which are normally the ones which will interact with the services and the data of the applications. And finally, we would have the presentation or dumb components just for the visual part. That's what we like. We developers love the style. What do you think about this, Estefanía? Well, I think it's fantastic. The last one, oh. So theory, super great, but let's see how we can apply it. We're going to take one of our feature models, the domain ones, with the characters, and we'll see in this module where all the different type of components are, the ones that Carlos has just explained. We have the first one, the container type, which is the page which shows everything. And we see it marked with a red line. Then we have two different smart components indicated with the yellow lines. And those are the ones which contain all the cards with the information and the characters in Dragon Ball. And finally, we have the container with the form. Then we have two dumb ones, which are the ones indicated in the dotted lines, the green dotted lines. So those are the components in charge of the purely or merely visual information we have with the characters and the form in itself. Well, I think it's great. We have reviewed already two aspects. So what is the next one? Okay, so we already have modules and components, but we need to communicate them somehow, right? So we need to communicate amongst them also. I'm going to leave the theory to you. So let's review how we communicate. But you're the PhD, I'm not the one. Okay, so I'll do the theory. I think we need to remove the view graph. Okay, next. Okay, very well. So basically, we're going to have two types of data flow, which are the patterns which will allow to communicate components amongst themselves. We have the unidirectional and the bidirectional data flow. And to understand how they work, it's very simple. Their own title tells you everything. The unidirectional consists in flowing data in one direction, while the bidirectional one flows the data in two directions. In the unidirectional one, the data goes only in one direction, like from the father to the children or to the sons, in the tree of components. Okay, so in our case, the idea would be controlled flow, unidirectional, where data flows down to the child components, from the smart ones to the dumb ones. And then the dumb ones will be able to communicate with the smart ones, letting them know that they need to do something, right? Yes, perfect. Well, now that we know what we want to do, let's go to the practical part. How do we do it? Okay. So this is like in everything in IT. It all depends. There isn't a silver bullet or just one solution for it all. It all depends on the system, the complexity, the requirements. A possible solution could be to have a service to contain, which would be the one to contain the status of the application, and it would be distributed into several components, and that way we can use it in the unidirectional and the bidirectional. But I see a problem. When we have to components requiring data of a service is providing data to several components. It's not really scalable. So what we need to have is solutions for what? Small and medium ones, which are totally valid. But if we need a scalable solution, there are tools which will, for example, provide a cable in our Angular. Yes, of course, there are tools for everything here. If you notice on the screen, we have three of the most famous tools which serve to manage the status of our application. Each one does it in a different way, but in the end, they're all practically based on the same concepts. And the three libraries are NGRX, XS, and Akita. XS and Akita. Very well. So I will explain NGRX, the way it works, because as you know, it's my favorite one. And 4 days ago, version 10 was just issued, so we need to study it and prepare ourselves. So the idea behind this, it can change. In fact, NGXS changes, but for our scalable talk, it remains the same. What we need to take into account is that of the smart components, you're going to derive actions, the character of Dragon Ball. And actions are the different operations to be carried out over our status of application. And the actions will allow, or what they do is they boost functions, which are the ones which will change the stored or the store of the application. The store would be the status of the application, as you can see on the screen. For every instant where we make changes. On the other hand, we would have selectors which will allow us to subscribe to portions of that status we have in the application and will allow us, or will allow the smart components to subscribe, to make a change, and talk about the smart and the dumb components. And finally, if we needed with something that is not totally related to the store, we would have the effects. What do you think? Yeah, Stephanie. Well, really, what you do implement this model. This requires a lot of work. You are aware of these. So let's take a look at what it implies to implement everything that Carlos has talked about in RGX. We've selected this, and let's see what it implies. For each unique feature module, which are the 5 modules, we need to generate new files, one for each concept, one for effects, another one for actions, etc. So once we have these ficheros and we've defined all the concepts and the parts we need, we proceed to make some changes in the code of our application. For example, if you notice the smart component, which is the one containing all the characters, we need to modify it. That it's going to go from having independent character service to all operations with the characters to another version of the same component, which instead of injecting the service, it's going to inject the store of the NGXS. And thereafter, you can carry out the dispatches, etc. This is what allows for the beginning of all these life cycle Carlos has talked about. So, did you have a problem? Because I can tell you the theory, but then when you start programming, you start seeing the problems, right? Have you had any problems? Well, the main problem with the use of this type of libraries is that each module in our application will be linked or coupled to the concrete implementation of the library we have selected. That is, we're going to generate an enormous number of dependencies in our code, and we perfectly know that the lesser the number of dependencies, well, the more scalable it's going to be. So yeah, that's a problem. So that gives rise for me to think about a pattern which is facade pattern, which allows us to hide the complexity of the system. So what's the facade pattern? Just simplifying it so that you can understand it. It's an object which allows us to have unified and simpler interface behind a more complex system. When can we use this design pattern? Well, to minimize the number of dependencies, simplifying interfaces with simple, concise methods, and it will allow us to abstract the UI components. Oh, please don't change the view graphs yet. Okay, so, Carlos, you love your diagrams and your boxers as a PhD, so please tell us more with some, dynamic features. So let's look at this. This is the facade pattern, design pattern. So let's imagine we have two systems implementing a series of classes that you will need. Another class would be for clients. The client has to become familiar with everything in the two systems to start using it. Okay, so what can happen with this? Or how can we improve it? Well, putting the facade in between. The facade would be the intermediate class which knows the interface of the two systems, and the client would only communicate with the facade. Simple interface. If you're going to change something from system 1 to system 2, it will be transparent for the client because it will communicate through the methods. Obviously, we need to update the facade, but it's only one site, which is the facade. Okay, but what happens if the application starts growing? Can you imagine? We have lots of systems that are growing and growing more and more. So if we only have one type of facade to contain all the information, this will turn into a gigantic class. And you know perfectly well that this goes against it's an anti-pattern. There you see the guy. So yeah, you have to kill it. That's right. We're seeing different facades, and we can create facades to the extent it grows. And we hide the complexity. I'll give you a simple example. We have the Pokemon system, for example, that you see in any post of a blog. So what do? Two facades, and the client will only communicate with the facade of the dragon or the other. Imagine you see 50 more theories. What can we do? Create intermediate facades, always hiding the complexity. Okay, I would buy it. So let's go into the code. Let's see the code. Let's take a look at the implementation of the super facade element. So basically, we would need to make two changes. We're going to create a facade class containing the complete logic of the library we have chosen. NGRX, in this case, we have a dispatch, the store injected, and a selector, right? So what we're going to do in this smart component where we priorly injected the store directly, having the code completely coupled, now we will install the facade. Okay, so in the case from the component, for example, we want to carry out an action or select a part of the status, we're going to do it through the facade. The client will not be aware of the logic. He will simply say, hey, update a character, and the facade will be in charge of doing it. What can we get with this? Have the code completely decoupled. Yes, great. I explained with theory and with practice. You're seeing it with the theory taken to practice. I have to be sincere. I'm missing a diagram or something like this, which can show everything we have talked about. Can we see it in a beautiful diagram? Well, I prepared it in case I had to show it. So here we can see the summary of the different layers or levels. In this case, we have organized service layers where we see the stage management, the services, one layer of facade, which will have or contain all the logic, and a view layer, which shows what we have been talking about. Besides, it read what we've done is the facade of the stage management. We haven't done the services one, which can also be done. And another diagram, the data flow diagram, very simple, would be this one, which summarizes everything we've been talking about so far. Right, I love this one much more. It's easier to see, it's friendlier, right? The actions go up and the data go down, the arrows go down, respecting the natural flow. Okay. Well, Carlos, I think we're reaching the end of this presentation. Yes, I think so. I think it's time to go to the. Before we say goodbye, we should make a summary, right, so that people can, become aware. I mean, that we're not just two people, making you get bored. Let's take a look at the summary. It's 5 super simple points. One, with modular design, we're going to have the application super well organized by functionalities. And then we use that with different types of components. We're going to have the components organized by responsibility. Views, smart, and done. And 3, data flow patterns. Will be perfectly controlled with the data flow that you mentioned before. The application grows, what do we need to do? Go to use a library to manage the status, and we can use the one we want for the reactive state management. And finally, we're going to hide all the internal complexity and have a code decoupling through the Facades chapter. Well, Estefanía, I think it's time for us to say goodbye and thank everyone for being here and following us. Follow us on Twitter. We're here for whatever you need. If you want to write to us, whatever you need. Thank you very much for listening to us. Thanks to the NG team in Colombia for what you're doing. And, well, see you next time. Thank you very much.
Great talk. Everyone is in love with you guys on the chat. And most of us are in love with what we do. So thank you so much. Thank you. What a great presentation. And just to explain for the Latin Americans, Bola de Dragón means Dragon Ball. So thank you. Did you know that 1,252 people heard your talk? Thank you, guys. And yes, what a pleasure. And we became a trendy topic. So yes, keep tweeting. And remember, NGConf 2020. Now we're going to have a small break, and we